So now let's see, we have suppose one example, if we have RC double bond O we have over here, and here if we have this Cl, right. So if I say here this CH2 and here we have this N and triple bond N and positive. So this is going to definitely attack on this carbonyl one, right, and this Cl will get removed if you will see, right, because first of all this will come over there and then again this will come back and this Cl will get removed. So here we will have something like this, here we will have something, sorry, so RC, here we will have this C and here we will have this double bond N plus and double bond this N as minus, like this. This will be formed in this case, right, something like this will be formed in this case. If I say about this reaction mechanism, suppose if I take one dicarbonyl compound like this, and if I treat it with TSN3, right, and NET3, so what will happen? Something like this can be formed in this case, right. I hope you understood about this one. Got it? If I try to write down the mechanism for this one, let's understand, because you might have got confused how we are getting this one. So first of all, if we have RC double bond O Cl like this, CH2 minus, if this is attacking over here, so this is getting shifted over here, right. So what we are getting, here we are getting R, this double bond O, this carbonyl one, right, and we will have this CH2 H over here and one more H over here like this, and we will have this N and this triple bond N and positive charge on this one. After this we again have this CH2 minus and N triple bond and this plus. So this will abstract this proton again from here, right, and this bond will shift over there. So in this case we are going to get something, sorry, here double bond and here we have this one. So that is the reason why we got this one. I hope you understood, right. So this is the mechanism and this is going to follow each and everywhere wherever you will see. Now let's see few more. So what happens if suppose if I take one more example like this, RC double bond and here we have this N double bond N plus and here we had this minus, right. If I treat it with some reagent like RH2OAC4 like this, so in this case actually this is going to form the carbene. This is carbene which you can see over here, right, like this. This is the carbene which will be formed. But if you will see what happens in this case, actually the carbenes which actually get formed over here, that is connected with this rhodium, and here suppose we have this ligand, right, whatever the ligand we have. So this carbene actually get connected with the ligand. So that is the reason such type of carbenes are actually called as carbenoid. Such type of carbenes are actually called as carbenoid, because this rhodium is actually the carbenes which we have over here. This is not much stable with this rhodium. If I use chromium or if I use tungsten, so in that case the carbenoids are actually much more stable, and that is a example of Fischer carbene, right. In the organometallic you will understand about the Fischer carbene and the Schrock carbene, right. So here we are not going to discuss much about them. Got it? Now let's take one more example of Bamford-Steven rearrangement. So what we had here, we had pH, here we had this double bond, and here let's take we have something like this. So first of all we were treating it with TSNH NH2 like this, right? So here we have this PH, here we have this double bond N, NH, and here we have this TS like this. After this, what was happening? After this, we were getting something like this PH. Here what we had, double bond N, negative over here, positive over here. So in that case, we were also getting the carbene, and this kind of example is actually example of Bamford Stevens, which we have discussed along with the Shapiro reaction, right? I hope it's clear now. So this is so many examples we discuss regarding this, and after this we can also have, if suppose if we have, if I take the example of actually Simon Smith reaction. So in that case we had like this ICH2H, something like this, and we were treating it with zinc copper couple. So we were getting ICH2 and this ZnI like this, right? And after this also we were getting CH2, here we had this ZnI like this, sorry, yeah, CH2I this side, and we also getting CH2I this side. If you remember, this reaction was happening in the Simon Smith reaction, and this is the example of carbenoid, right? Yeah, so this is much about the how actually the carbene formation takes place. And now let's take few more examples, there you can understand. These all examples whatever I discuss with you, they are from the standard reference books and all, so you can find it over there in the Clayden or the Carruthers and all, right? Now let's understand few more examples, and then we will move to the reactions of the carbene. So first of all, if I say, if we have something like this RC, here we have this R and here we have this double bond N2, right? If I treat it with photon, so in that case that will get converted into the carbene. So that is the one process. Now if I take few more, so in that case what will happen, as I discuss RC double bond O we have over here, right? And here what we have, CH, and we have this double bond N and this double bond N and this positive and this negative. In this case that is also going to form RC double bond O, and here we have this type of carbene, right, which we discussed, like this can undergo Wolff rearrangement reaction. Got it? Now if I take few more, so if I take, we have suppose R2, here we have this C, and here we have this double bond N, right, and I can add an SO3AR, something like this, right, sulfonyl hydrogens like this. If I either I can heat it, so it will become R2C like this, plus N2 will be removed and AR SO2 minus this AR, which you can see over here, right, the AR which you can see, sorry, this is not SO3 but this will become SO, so AR SO2 will be removed from here, right, like this. Now if I talk about the next method, in the next method we can have from the ketene, right? If we have the ketene, as I told you, RC, here if we have this like this ketene, if I heat, then what can happen, this ketene can also give you the carbene. How this can give you carbene, RC double bond O, and here we can have this RCH like this. Such kind of carbene can take place like this if it undergoes rearrangement, or apart from this I talk, so it can also give you R, C, here H like this, and CO can be removed if I heat it strongly, right? So this can also be formed. So such kind of carbene can take place. If I take example of epoxides, so what happens in case of epoxides? Can epoxides give carbene? Yes, they can. We have this as epoxide. If I treat it with photon, so what will happen in this case? We can have RCR over here like this part, and then in the next part we will have R, C double bond O, and here we have this R and this R, right? Now let's take few more one from where they can be formed. Now they can be formed from the diaziridine. So what are diaziridine? So here we have this N double bond N like this, and here we have this C and this C like this, and this R and this R, right? So if I treat it with photon or heating it, can give you this kind of reaction. So here the carbene can also be formed. Now if I talk next, so what can happen? If I take R, C, here we have this R, right? And here we have this halide. Let's say we have R2 over here, R2 over here, like this, right? Negative charge over here and positive charge over here. So if I heat it, then what will happen? We can have this carbene plus SR2 can be over here from the halide, right? Halide or halide, whatever you call it. Yeah, so that's good enough number of examples actually which we have discussed from the standard reference books and from the basics of the carbene formation, how the carbene formation can actually takes place, right? So this is much about the carbene formation and all, and from you can't expect the questions formation of carbene from out of this, right? So because we have already almost discussed each and everything regarding this carbene formation, how the carbenes can be formed, right? And in this part, in this lecture series, in the next part, we are going to discuss about the, first of all we will discuss about the reaction of carbene, right? We will discuss about the reaction of the carbene, and after this we will also discuss along with that previous year question and many more practice questions regarding the carbenes and all, right? And in that case we are going to actually cover the things which you might not have studied from anywhere, or you must not have studied from your books, or actually, because I know that most of the people are not going to study books and all for the organic, because that becomes little complicated and people actually have shortage of time. So what I will do, I will try to find out the examples related to the concepts whatever we are actually studying over here and I am teaching to you, right? And I will try to discuss those examples from the Clayden, Carruthers and all these all kind of books, whatever the standard books which we have, right? Like in this carbene formation, you saw the many questions which were here. So they were from the actually Clayden. So if you will practice them, because you might have seen the questions were quite lengthy, right? They are very much tricky. The structures, whatever you will see, actually that are bigger ones. So that is the reason actually most of the people get afraid to understand the organic. Yeah, so that's all for this video, and thank you so much for watching this video. If you're watching this video on YouTube, so please subscribe to our channel and don't forget to press the bell icon. Thank you.